Hello everyone. So today we are going to solve GFGPOD and the problem is ancestor in binary tree. So let's go with the problem statement. So here it is given binary tree and an integer target. So we have to find all the ancestor of a given target, and we have to note that ancestor of a node x is node y, which is at the upper level of node x, and x is directly connected with node y. Consider multiple labels of ancestor to solve this problem. In case there are no ancestor available, return empty list. Right, so here let's see the example one. So here a binary tree is given and target is given. Target is 7. So all the elements which are in the above label, that will be considered as the ancestor of the current node. Whatever are coming in the traversal till the current node, and whatever the nodes we are traversing from a root to the that current node, and all those parent node will be considered as the ancestor. So like for 7 we are having parent 4, then 2 and 1, not 5, 6, 8. Not like all the we will consider just the parents, like whatever the parents we are getting in the traversal, not the other, like other elements which are in the above level, like 5, 6, 8 are also in above level, but these are not ancestor. So like for a example here, if the root node is only given as the target, so its ancestor is nobody here. No node is having its ancestor value. It is the only node uh, which starts with 1, and that's why it does not have any ancestor. So let's go for the code. And firstly we are going to traverse this in order traversal, and whenever we are getting the target, we will just return from here there only, and we will just keep the value inside our list array list, and we will traverse each and every node, and we will check whether the current node is target or not. If target, we will get the target, then we will return from there only. So let's go for the code. So here firstly we are going to take an array list which will be outside of the function given, because we are going to make it as global for our scenario, and it will be the list of integer. Now we will make a solve function here where we will pass root and target, and obviously list is outside the function which can be used by any of the function in the class solution. So here we will use a boolean type of solve, because if we are getting any value in the left or right of its subtree, then the current node will also be ancestor of that node. Let's suppose 2 is searching for its subtree, whether its subtree is having the target value or not. If its target value is found in inside subtrees, then it will also be a ancestor. So this should be counted as ancestor and should be included in the list. So for that we are using boolean. So here we will pass the node root and then in target, sorry, and then we will pass, if root is null, then we will just return false, because it means that we traversed till the last node but we didn't get the target value, so we will just return false here. If any case where we will get the target is equal to root dot data, then we will just return true. Otherwise we will traverse in the left subtree and the right subtree. So let's go for the left subtree, and target will be the same, and solve root dot right. If we got any subtree as true value, means let's suppose 2 is having true value in its left subtree, it means 7 is found in its left subtree. It means that 2 is also a ancestor. So that should be like, if any of the subtree is having the value as true, then we will just going to make it as going to include that inside our list. So here we will check if left or right, then we will include the value inside the list. And here also, before returning, we will just okay, no, we have not to add the value of the target value, but the ancestors, whatever the parent values and the parents value. So we have to return from here, return left or right. If current node has any value as found the target, then it will return the current value, will also return the true value, because let's suppose 2 is having uh, its subtree as 7. So 2 is an 2 is an ancestor, and 2 will return true, such that one can get that, yeah, one of its subtree is having the target, so one will also considered as ancestor. So let's return from our main function, return the list, and let's try to compile and run it. Okay, here we can see 5, 2, and 1, and expected is also 5, 2, and 1. So let's see some other examples. So let's take another values 11, 12, 13, 14, and then we will try to find out 12. So here we can see 6, 3, and 1 are included in our ancestors list, and expected solution is same as our input. So let's submit it. So it got accepted. I have already solved this, but to show the solution, I have resolved it, and I shared my intuition behind the problems. So this was the solution and intuition behind this problem. And if we discuss about the time complexity, then we are traversing through each and every node, and in worst case, we have to traverse each and every node, because let's suppose our target value is at the rightmost value, then we have to traverse all the nodes. So there our time complexity will be big O of n. And yeah, if we talk about space complexity, then space complexity is also, I think, yeah, it's auxiliary space is also height of the tree, because we are using auxiliary space to store the values till the height of the tree, and to return the values inside list, we are obviously we have to use the list. So that is needed. And yeah, so this was the complexity and the problem solution. I think this was helpful to you. Thank you.